Did you ask ChatGPT to check your schedule this morning? Did you play Spotify on your way to work or scroll through shorts during lunch? If so, you've already connected to data centers dozens of times today. All you did was open an app, but behind the scenes, massive servers and GPUs were running nonstop. So what happens if the power goes out for just 0.1 seconds? In a data center, even a tiny power fluctuation can stop servers, interrupt services, and disrupt data processing. In 2021, just before Christmas, a power-related incident struck an AWS data center in Virginia. Within minutes, people across the eastern United States saw their TVs freeze and their pizza delivery apps stop working. Many users were probably refreshing their screens, wondering, is my Wi-Fi down? Nope. The real problem was the power infrastructure behind the internet. According to Uptime Institute, 20% of major data center outages cost more than $1 million. One tiny flicker of electricity can cause losses worth dozens of brand new EVs. Until now, backup power has mostly been provided by large centralized systems that cover an entire data center. These are called UPS, or uninterruptible power supply systems. A UPS instantly switches to battery power during an outage or voltage fluctuation, allowing connected equipment keep running or shut down safely. But with the rise of AI servers, traditional UPS systems are starting to reach their limits. So why is that happening? Let's compare the numbers. A typical server uses about 0.5 to 2 kilowatts of power, but a single NVIDIA DGX H200 AI server can consume up to 10.2 kilowatts. That's up to 20 times more power. And data centers are packing each rack with multiple servers like this, all running side by side. The problem is that this power demand doesn't stay constant. During AI inference, it can surge, drop, then surge again in an instant. It's like turning an air conditioner down, then back up, then down again. Now imagine thousands of GPU servers doing that at the same time. A centralized UPS that supplies power to the entire building has limits when it comes to responding to changes that fast. The power lines are long, and there are multiple conversion steps in between. Even a split-second delay can lead to data loss, and, in the worst case, millions of dollars in damage. That's why AI data centers need a backup power system that can respond instantly right next to the servers. That's where BBU, or Battery Backup Unit, comes in. Think of an AED at an airport or shopping mall. In an emergency, there's no time to wait for hospital equipment to arrive. That's why AEDs are placed where people can reach them quickly. Data centers work the same way. If UPS is the large emergency system protecting the whole building, BBU is like an AED placed right next to the server rack. The moment power becomes unstable, it responds from the closest possible point, helping keep the system running. Here's the simple breakdown. A backup time of 4 minutes may sound short, but it's enough to bridge the gap until the UPS and emergency generators take over. Think of basketball. A BBU is like a substitute player who steps in just long enough for the starter to get back on the court. So what kind of battery does a BBU need? Hit subscribe and let's take a closer look. A BBU has to deliver a large amount of power instantly inside a narrow server rack. It has to last a long time and operate safely in high-temperature zones where heat builds up, such as behind server racks. That means it needs 4 key qualities. First, high power. AI servers can demand tens of kilowatts in an instant. If the battery can't deliver that peak power immediately, it can't do its job. Second, high energy density. Space inside a server rack is limited. That means the battery needs to store as much energy as possible in a compact size. Third, high efficiency. Data centers use enormous amounts of electricity, so minimizing energy loss during charging and discharging is critical. The less energy that is wasted, the lower the operating costs. Finally, safety. In high-power environments, batteries generate a lot of internal heat. That means they need to operate reliably even when temperatures rise, and be designed to prevent that heat from turning into a dangerous situation. To meet all 4 of these requirements, the industry is quickly moving from traditional lead-acid batteries to lithium-ion batteries. Among them, LFP batteries stand out for their excellent fire safety and long cycle life, making them increasingly popular in the BBU market. A BBU is like a seatbelt. You don't think about it every time you get in a car, but the moment something goes wrong, it makes all the difference. And right now, the number of cars that need that seatbelt is growing fast around the world. Microsoft plans to invest $80 billion in data center infrastructure in 2025 and 2026. Amazon, Google, and Meta have also announced massive investments. Every time a new data center is built, thousands of server racks are installed, and each of those racks may need a BBU. That's why battery companies are paying closer attention to the data center market. At Interbattery 2026, LG Energy Solution unveiled its BBU solution for AI data centers. The company showcased a BBU using high-power cylindrical batteries, along with an LFP-based UPS rack system. It showed how the battery market is expanding beyond EVs and into data center power infrastructure. Delta Electronics is also actively rolling out BBU systems for AI data centers. At the 2025 OCP Global Summit, the company unveiled a 72 kilowatts BBU system focused on smaller, more efficient, rack-level backup power. As AI servers consume more and more electricity, delivering backup power instantly at the rack level is becoming increasingly important. These two examples make one thing clear. A BBU is much more than a few batteries connected together. It is a complex system that integrates battery cells, power management systems, and the power infrastructure that connects directly to the servers. As AI servers demand more electricity at higher speeds, data centers need power systems that are more stable and faster to respond. And at the center of that shift, the BBU is becoming a critical piece of infrastructure. In the AI era, data centers can't afford to stop. A BBU protects that tiny 0.1 second moment. If EV batteries keep cars moving, BBUs helps what keep the AI world running. If you want to follow where the battery market is heading next, hit like and subscribe. And if there's a battery topic you'd like us to cover, drop it in the comments. We'll see you in the next video.